March 1943. The North Atlantic had become a graveyard. Every single day, an average of 5 Allied merchant ships vanished beneath the waves, torn apart by German U-boat torpedoes. Submarines hunting in coordinated wolf packs were winning a war of mathematics, and the numbers were brutal. They were sinking cargo vessels faster than American and British shipyards could replace them. Admiral Karl Donitz commanded over 200 U-boats, and his crews were winning the tonnage war that would determine whether Britain starved or survived. The statistics told a story of approaching catastrophe. In March alone, U-boats sent 108 Allied ships to the bottom, representing over 727,000 tons of desperately needed supplies. That single month erased half a year of shipbuilding progress. Wheat rotted in Canadian silos because there weren't enough hulls to carry it across the Atlantic. Steel that should have armed British factories rusted in American ports. Aviation fuel meant for Royal Air Force bombers fed fires in the mid-Atlantic instead. Convoy duty had become something every sailor understood as a death sentence. Of 43 ships that departed New York with convoy SC-22 in early March, 9 never reached Liverpool. That's a 21% casualty rate for a single crossing. The slower HX-229 convoy travelling parallel lost 13 vessels in 72 hours. Survivors treading water in the frigid Atlantic watched submarines surface to count their kills, then dive again to hunt the next target. Escort destroyers racing toward one sinking ship would hear torpedo explosions from 3 different directions, helpless to protect vessels scattered across 50 square miles of ocean. The Wolfpack system was devastatingly effective. German headquarters would position 20 to 30 submarines in a patrol line, stretching 500 miles across convoy routes. When one U-boat spotted merchant ships, it would shadow the convoy and broadcast position reports. Other submarines would converge, then attack simultaneously from multiple bearings at night when lookouts couldn't spot periscopes. By dawn, the wolves would scatter beyond the range of Allied escorts and regroup for the next ambush. British Admiralty statisticians calculated that at current loss rates, the merchant fleet would cease to exist by autumn 1943. Every military operation planned for 1944, including any invasion of occupied Europe, depended on cargo capacity that was evaporating 6 ships at a time. The United States was producing equipment and vehicles at unprecedented rates, but it didn't matter if those supplies couldn't cross the Atlantic. Britain's food imports had dropped to 2/3 of peacetime levels. Rationing tightened week by week. The Allies knew exactly what they needed: aerial coverage over convoys. Land-based aircraft from Newfoundland and Northern Ireland could protect ships near coastlines, but a gap existed in the mid-Atlantic, 800 miles wide, where no plane could reach. This black pit became the wolf pack's hunting ground. Submarines could surface, recharge batteries and attack with near impunity, because there were no aircraft to force them underwater where they were slow and vulnerable. Long-range bombers remained committed to bombing German cities. Fleet carriers protected invasion forces in the Pacific. The Atlantic convoys sailed with destroyer escorts that could only react after torpedoes struck, racing to chase sonar contacts while more ships burned. Spring 1943 represented the crisis point, the moment when Germany appeared, positioned to win the one campaign that would render all other Allied victories meaningless. Without Atlantic supply lines, there would be no second front, no liberation of Europe, no victory at all. The solution arrived in the most unglamorous form imaginable: a merchant ship with a flight deck welded on top. While naval architects dreamed of 30,000-ton fleet carriers with armor plating and 30-knot speeds, an industrialist named Henry Kaiser proposed something radically different. Take the basic hull of a merchant vessel, flatten the top, add a flight deck, island superstructure, and catapult system, then push the entire contraption out of the shipyard in 90 days. The Navy called them jeep carriers or baby flattops, and most admirals considered them barely adequate for training purposes. Kaiser's Vancouver shipyard in Washington state revolutionized carrier production through methods that horrified traditional naval constructors. His workers prefabricated entire sections of hull and superstructure in assembly line fashion, then welded them together rather than using rivets. This violated generations of shipbuilding practice, but it worked. The first Casablanca-class escort carrier, USS Casablanca herself, launched on April 5, 1943, after just 5 months of construction. A fleet carrier required 2.5 years minimum. Kaiser promised to deliver 50 escort carriers in 18 months, and defense officials who remembered his Liberty ship miracles believed him. The specifications made fleet carrier captains wince. These vessels displaced 11,000 tons compared to a fleet carrier's 27,000. Their diesel engines could barely push them to 19 knots, fast enough to keep pace with merchant convoys but hopelessly slow by combat standards. The flight deck measured only 477 feet long, forcing pilots to land on a platform shorter than most fleet carriers' hangar bays. Each ship carried 27 aircraft crammed into a tiny hangar deck where mechanics worked elbow to elbow. There was no armor plating protecting magazines or fuel tanks. A single torpedo could turn an escort carrier into a fireball. Cost analysis told the real story. Each escort carrier required approximately $7 million to build. A fleet carrier cost north of $100 million. For the price of one Essex-class fleet carrier, Kaiser could deliver 15 escort carriers with over 400 aircraft combined. The British Admiralty grasped the arithmetic immediately and ordered 23 escort carriers under Lend-Lease before the first American hull hit the water. The US Navy remained skeptical, viewing these vessels as compromises forced by wartime desperation rather than legitimate weapons. Naval aviation officers compiled lists of deficiencies. The short flight deck meant aircraft had to be launched lightless ammunition, less fuel, minimal bomb loads. The slow speed meant escort carriers couldn't keep pace with fast carrier task forces in the Pacific. The lack of armor meant they'd be death traps if they encountered enemy surface ships or submarines. Critics pointed out that these were merchant hulls with flight decks, not warships. Assigning them to protect convoys seemed reasonable. Expecting them to hunt submarines seemed delusional. What the skeptics missed was that convoy escort didn't require fleet carrier capabilities. Merchant convoys plodded along at 10 knots. An escort carrier's 19-knot maximum speed made it race-car fast by comparison. The short flight deck didn't matter for the Grumman TBF Avenger torpedo bombers and Wildcat fighters assigned to anti-submarine duty. Both could operate from the available space. Armor plating would be useless against torpedoes anyway. The real question was whether these improvised platforms could put aircraft over submarines in the Black Pit, and whether those aircraft could sink U-boats before wolf packs tore another convoy apart. By May 1, 1943, 6 escort carriers had joined the Atlantic Fleet. Each one represented a $70 million gamble split 50 ways. The Navy was about to discover whether mass-produced adequacy could defeat precision engineering. These escort carriers carried aircraft, but those aircraft needed something better than depth charges to kill submarines. Traditional depth charges had a fatal flaw. Destroyers had to pass directly over a U-boat's position before dropping them, and the explosions would blind the ship's sonar for 15 minutes. Submarines simply dove deep and maneuvered away, while escorts groped blindly through disturbed water. Kill rates hovered around 4%. Depth charges worked brilliantly at keeping submarines submerged and away from convoys, but actually destroying them remained frustratingly rare. A British naval engineer named Charles Goodavay invented the answer in 1941. The Hedgehog system mounted 24 Spigot mortars in 4 rows on a ship's foredeck. Each mortar launched a 65-pound projectile in a circular pattern, 250 feet ahead of the attacking vessel. The projectiles didn't explode on contact with water like depth charges. They only detonated on direct contact with a submarine's hull. This eliminated the depth charge problem entirely. Ships could fire, maintain sonar contact, and immediately know if they'd hit. No explosion meant a miss. An explosion meant a kill. The mathematics of probability made Hedgehog devastating. 24 projectiles landing in an elliptical pattern 140 feet across gave each attack roughly a 25% chance of scoring at least one hit against a submarine. One hit would punch through the pressure hull, and the resulting implosion would finish the job. By spring 1943, Hedgehog-equipped escorts were sinking one U-boat for every 5 attacks, a 500% improvement over depth charges. The other technological revolution arrived in an unassuming black box called HFDF, which sailors pronounced Huff-Duff. High-frequency direction-finding equipment could detect and triangulate German radio transmissions. U-boats had to surface to recharge batteries and communicate with headquarters. Every radio message gave away their position. A single escort with HFDF could determine the bearing to a transmitting submarine. 2 escorts comparing bearings could pinpoint the location within 5 miles. 3 escorts could fix a position accurate enough to vector aircraft directly to the target. German submariners never suspected their communications network had become a targeting system. Admiral Donitz's Wolfpack tactics required constant radio chatter, submarines reporting convoy positions, headquarters directing attacks, U-boats coordinating movements. Each transmission drew a line across Allied plotting tables. The more submarines coordinated, the more precisely escorts could locate them. By May 1943, nearly every American and British escort ship carried HFDF equipment calibrated to German naval frequencies. The combination transformed anti-submarine warfare. HFDF would detect a submarine radioing position reports. Escort carriers would launch aircraft to the coordinates. Avenger pilots would spot the surfaced U-boat and force it to crash dive. Hedgehog-equipped destroyers would race to the location and attack while the submarine was still maneuvering at slow speeds. If the first spread missed, sonar held contact and the destroyer could attack again immediately instead of waiting for depth charge disturbances to clear. U-boat commanders found themselves hunted by enemies who seemed to read their minds. Submarines that surfaced to charge batteries would suddenly have aircraft overhead. U-boats transmitting convoy sightings would face destroyers appearing from nowhere. The technological advantage Germany enjoyed through 1942 had evaporated. American research laboratories and British engineering workshops had produced weapons that turned the hunters into prey. All that remained was proving these systems worked in actual combat. USS Bogue launched her first anti-submarine patrol on May 1, 1943, with 9 Avenger torpedo bombers and 12 Wildcat fighters aboard. Her commander, Captain Giles Short, had explicit orders from Atlantic Fleet headquarters. Aircraft would patrol at 3,000 feet altitude minimum, attack only confirmed submarine contacts, and follow established doctrine for depth charge deployment. The pilots nodded during the briefing, then promptly ignored every instruction once they cleared the flight deck. Lieutenant William Fowler found a U-569 on May 2nd, 70 miles from the convoy Bogue was escorting. The German submarine was running on the surface, recharging batteries in what the crew assumed was safe mid-Atlantic emptiness. Fowler's textbook approach would involve climbing to bombing altitude, making a careful approach and releasing depth charges from 1,500 feet. Instead, he pushed his Avenger into a dive that brought him 50 feet above the wave tops, throttled to maximum speed, and released his depth charges while the U-boat's deck crew scrambled for the conning tower hatch. 3 explosions straddled the submarine's pressure hull. U-569 went down stern first with all hands. Naval regulations prohibited such attacks for good reasons. Low-altitude depth charge drops risked destroying the attacking aircraft with blast fragments. The shallow approach gave submarines maximum time to crash dive to safety. Pilots were supposed to gain altitude, make precise calculations, and deliver ordnance from heights that allowed safe escape. Fowler's attack violated procedures established by officers who'd spent years studying optimal bombing tactics from comfortable Pentagon offices. On May 5th, Lieutenant Junior Grade Stuart Doty located U-231 surfaced and transmitting position reports. Doty repeated Fowler's unauthorized tactics maximum speed approach at minimum altitude. His depth charges detonated directly beneath the submarine's conning tower. The pressure wave buckled the hull in 3 places. German survivors later reported the boat flooded so rapidly that only 7 men escaped before she sank. Doty returned to Bogue, filed a combat report describing his low-altitude attack, and expected a reprimand. Instead, Captain Short quietly filed the report without forwarding it to Atlantic Fleet Command. The third kill came on May 9th when Lieutenant Commander Charles Hutchins caught U-752 partially submerged. The German captain had seen the Avenger approaching and begun his crash dive, but the conning tower remained visible. Hutchins dropped to wavetop height and released 4 depth charges that bracketed the swirl where U-752 had disappeared. One charge functioned as designed. It sank to the submarine's depth and detonated against the hull. The pressure wave collapsed the control room. 43 German sailors drowned in 90 seconds. 3 U-boats destroyed in 9 days represented more kills than most escort carriers would achieve in their entire service lives. The tactics violated every established doctrine, but the results spoke clearly. High-altitude approaches gave submarines time to dive. Low-altitude attacks caught them vulnerable on the surface. Pentagon planners assumed aircraft needed altitude for accuracy. Actual combat proved that closing speed and surprise mattered more than textbook procedures. Word of Bogue's success spread through the escort carrier fleet. Pilots compared notes during refueling stops in Norfolk and Argentia. The official doctrine remained unchanged, but every aviator understood the real message. Mechanics cranking propellers and pilots facing U-boats knew more about killing submarines than staff officers studying attack profiles. The 9 days from May 1st through May 9th established the template that would sink 38 more U-boats before the month ended. The pilots weren't the only ones ignoring regulations. Down on Bogue's hangar deck, aviation machinist's mate second-class Robert Henderson was installing auxiliary fuel tanks in the Avenger torpedo bombers using parts scavenged from damaged aircraft. Each tank added 45 gallons of aviation fuel, extending the Avenger's combat radius from 250 miles to nearly 400. This modification violated Navy Bureau of Aeronautics specifications, hadn't been approved by any engineering board, and would absolutely get Henderson court-martialed if the wrong officer noticed. The range problem had become obvious during the first patrols. Avengers would locate U-boats at the edge of their fuel range, attack, then race back to the carrier with engines sputtering on fumes. Submarines that survived the initial attack could surface and escape once the aircraft departed. Henderson's solution involved welding brackets inside the bomb bay, installing flexible fuel lines, and connecting everything to the main tanks through a hand pump system. The entire modification took 6 hours per aircraft and cost approximately $15 in materials. It doubled the time pilots could remain over suspected submarine locations. Lieutenant Commander John Cronin, Bogue's Air Group commander, walked through the hangar deck on May 7th and found 3 Avengers with unauthorized fuel tanks installed. Henderson braced for the reprimand. Cronin examined the welds, checked the fuel line connections, and asked how many aircraft Henderson could modify before the next patrol. The official memo Cronin filed reported field maintenance adaptations to enhance operational capability. The unofficial message to his mechanics was simpler: install the tanks on every bomber and keep your mouths shut. Wildcat fighter pilots faced a different problem. Their aircraft carried 650 caliber machine guns effective against surfaced submarines, but the bullets lacked penetrating power against pressure hulls. Aviation ordnanceman First Class James Mitchell solved this by fabricating rocket rails from salvaged aircraft tubing and electrical conduit. Each Wildcat could carry 2 5-inch high-velocity aircraft rockets under the wings. The rockets weren't officially certified for the Wildcat airframe, and Mitchell's improvised mounting system would never pass a Bureau of Aeronautics inspection. The rockets also worked beautifully, punching through submarine conning towers like paper. The modifications spread through the escort carrier fleet faster than official procurement channels could have managed. Mechanics on USS Card copied Henderson's fuel tank design. Ordnancemen on USS Core improved Mitchell's rocket rails with reinforced mounting brackets. Aviation metalworkers on USS Santee developed drop tank systems that carried 60 gallons of fuel and could be jettisoned before combat. None of these modifications appeared in official technical manuals because official technical manuals required 12 months of committee reviews and engineering studies. The war would be over before the bureaucracy approved anything. Officers split into two camps. Traditional commanders threatened disciplinary action and insisted mechanics follow approved procedures. Pragmatic commanders like Captain Short pretended not to notice unauthorized modifications while quietly ensuring their own mechanics had access to the same innovation. The pragmatists won by default because their aircraft were sinking submarines, while the traditionalists were filing paperwork. The German Navy never understood what had changed. Their intelligence reports noted increasing escort carrier effectiveness but attributed it to better pilot training or improved tactics. Nobody in the Kriegsmarine suspected that American mechanics were re-engineering aircraft between patrols using welding torches and salvaged parts. Admiral Donitz's staff analyzed attack profiles and kill rates, searching for patterns in what they assumed were officially sanctioned American developments. They missed the fundamental reality the United States was winning through improvisation that would have gotten Soviet engineers shot and German technicians demoted. American mechanics simply built what worked and asked permission later, if they remembered to ask at all. The weapons modifications arrived just in time. On May 10th, 4 escort carrier groups Bogue, Card, Core and Santee began coordinated patrols across a 1,000-mile stretch of the North Atlantic. Admiral Royal Ingersoll had positioned them to cover convoy routes where wolf packs traditionally concentrated. HFDCF stations detected 43 German submarines transmitting position reports across the operational area. For the first time in the Atlantic War, Allied forces had enough aircraft to hunt every contact simultaneously. USS Card's aircraft killed U-174 on May 10th using Henderson's extended-range fuel tanks. The submarine was running submerged 100 miles from the nearest convoy when Lieutenant Richard Rogers spotted the telltale periscope wake. Rogers circled for 2 hours, something impossible without the auxiliary fuel, until U-174 surfaced to recharge batteries. 4 depth charges ended the boat instantly. On May 11th, Bogue's fighters caught U-528 on the surface and destroyed it with Mitchell's improvised rockets. The 5-inch warheads punched through the conning tower and detonated inside the control room. 12 survivors made it into life rafts before the submarine went down. May 12th brought 3 kills. USS Core's aircraft sank U-456 in the morning. Bogue's group destroyed U-89 that afternoon. Santee's planes caught U-176 after dark, using newly installed airborne radar that could detect surfaced submarines at 10 miles. The radar technology was so new that pilots were still learning to interpret the green scope images, but it worked. U-176 never knew aircraft were overhead until the depth charges exploded alongside her pressure hull. German submariners began radioing distress calls that HFDF stations intercepted and decoded within hours. U-boat command headquarters in Paris received reports of aircraft appearing from nowhere, attacking at wave-top altitude, and destroying submarines before they could crash dive. Admiral Douinetz ordered submarines to remain submerged during daylight and surface only at night, but escort carrier aircraft began flying night patrols using radar guidance. The darkness that once protected wolf packs had stopped providing cover. The killing accelerated. May 13th, 2 U-boats destroyed. May 14th, 3 more. May 15th, 4 submarines sunk, including U-266, whose survivors reported being attacked by aircraft 3 times in 6 hours by planes that shouldn't have had enough fuel to reach their location. Henderson's fuel tanks had turned the mid-Atlantic from a sanctuary into a hunting ground. By May 16th, German submariners were calling the Atlantic the Valley of Death. Boats that departed French ports with 50-man crews were disappearing with no survivors, no wreckage, nothing but oil slicks marking where they'd died. May 17th brought the worst single day. 6 U-boats went down across the North Atlantic, destroyed by aircraft from all 4 escort carrier groups working in coordinated sweeps. Destroyers equipped with Hedgehog finished off submarines that survived the initial air attacks. U-273 survived 4 depth charge attacks but couldn't escape the Hedgehog spread that followed. The projectiles bracketed the submarine and 3 struck home. The pressure hull imploded at 400 feet depth. By May 20th, 28 U-boats had been destroyed in 11 days. Donitz's Atlantic force was being gutted. Submarines leaving French ports were receiving recall orders before they reached operational areas. Boats already on patrol were abandoning their positions and running for home. On May 21st, 2 more U-boats died, U-467 and U-569. The latter's crew had time to radio a final message before going down. Aircraft everywhere. Cannot surface, cannot fight. The economics of submarine warfare had shifted in a way Admiral Donitz couldn't reverse. Each Type 7 U-boat cost approximately 6 million Reichsmarks to construct, equivalent to roughly $2.4 million at wartime exchange rates. The Blohm & Voss shipyard in Hamburg could build 1 submarine every 6 weeks using 500 skilled workers and materials that included precision instruments, high-grade steel, and advanced electrical systems. These boats represented the pinnacle of German engineering. Pressure hulls tested to 750 feet, diesel engines producing 2,800 horsepower, torpedo tubes machined to tolerances measured in thousandths of an inch. American escort carriers were sinking these engineering marvels, using aircraft that cost less than a luxury automobile. A Grumman TBF Avenger cost the Navy approximately $42,000. A Wildcat fighter cost $29,000. The 4 depth charges each Avenger carried cost $150 apiece. An attack that killed a U-boat consumed roughly $43,000 in aircraft operating costs and ordnance. The return on investment was staggering. Spend less than $50,000, eliminate a $2 million submarine, and 50 trained crew members who'd taken 18 months to train. Kaiser's shipyards were producing this destruction at rates German industry couldn't match. Vancouver launched 1 escort carrier every 32 days through spring and summer, 1943. Each vessel cost $7 million and carried 27 aircraft worth approximately $1 million combined. That $8 million package could cover 20,000 square miles of ocean and sink an average of 4 submarines during its operational lifetime. Simple arithmetic said an escort carrier would destroy roughly $9,600,000 worth of U-boats before retiring from service. Even accounting for the carrier's own construction cost, the United States came out $4 million ahead while simultaneously saving thousands of merchant sailors' lives. German shipyards couldn't match American production rates because they couldn't match American industrial philosophy. U-boats were precision-crafted using specialized components manufactured to exacting standards. Each submarine required 6 months of construction time because craftsmen assembled complex systems by hand. Blohm & Voss could increase production slightly by hiring more workers, but fundamental bottlenecks existed in component manufacturing. There were only so many precision periscope assemblies available, only so many torpedo tube forgings, only so much high-grade steel that met marine specifications. American shipbuilding operated on opposite principles. Escort carriers used commercial-grade steel. Their engines came from merchant ship production lines. Flight deck catapults were simplified versions of fleet carrier systems. Electrical components used civilian manufacturing standards. Kaiser's workers weren't craftsmen. They were welders, riveters, and assemblers working shifts around the clock. Quality control meant good enough to complete the mission, not perfect according to specifications. An escort carrier's lifespan might be shorter than a fleet carrier's, but it only needed to last long enough to sink submarines, and it accomplished that mission perfectly well. The math became untenable for Germany by late May. 38 U-boats destroyed represented approximately $91 million in direct construction costs, plus the irreplaceable loss of 1,900 trained submariners. German shipyards could build roughly 12 new U-boats per month. May's losses exceeded 3 months of production. The Wolfpack system depended on having enough submarines to saturate convoy routes. With boats disappearing faster than replacements arrived, Dönitz faced a problem no tactical brilliance could solve. His weapon system had become obsolete. On May 24, 1943, Admiral Dönitz sent encrypted orders to all Atlantic U-boats, withdraw from patrol areas and return to base. The Wolfpacks that had nearly starved Britain were retreating. The withdrawal order marked Germany's first strategic defeat in a campaign they'd chosen to fight. Hitler had explicitly told his admirals that victory in the Atlantic would decide the war's outcome. Control the shipping lanes and Britain would capitulate without requiring a single German soldier to cross the English Channel. Lose the Atlantic and the Reich would face invasion from the west while bleeding to death in the east. May 1943 determined that outcome. The 11 days from May 10th through May 21st killed 41 U-boats total, when counting earlier and later kills, not just the 38 from the concentrated period, and ended Germany's ability to wage offensive submarine warfare. The strategic consequences rippled outward immediately. Allied merchant ship losses dropped from over 600,000 tons in March to under 200,000 tons in June. By July, losses fell below 100,000 tons monthly. Convoys that had suffered 20% casualties in early 1943 were crossing the Atlantic in August with 0 losses. The mathematics that showed Britain starving by autumn reversed completely. Food imports increased. Steel stockpiles grew. Aviation fuel flowed freely to RAF bomber bases, preparing for the eventual invasion of France. General Dwight Eisenhower, planning Operation Overlord from his London headquarters, received updated shipping projections in July 1943. The numbers showed he could count on transporting 40 divisions across the Atlantic, along with their vehicles, artillery, ammunition and supplies, without fear of catastrophic losses. D-Day became logistically possible because escort carriers had broken the U-boat threat. Without those 11 days in May, the invasion of Normandy would have been delayed by at least a year, possibly 2. Every month of delay meant thousands more deaths in concentration camps and millions more civilians suffering under Nazi occupation. Germany attempted to rebuild the U-boat force but never recovered the initiative. New submarines left French ports in June and July, only to find aircraft everywhere. Dönitz ordered the development of snorkel breathing systems that let submarines recharge batteries while remaining submerged, but these didn't deploy until early 1944. He demanded faster submarines with better underwater endurance, resulting in the Type X-1 U-boat design. But these revolutionary vessels didn't enter service until April 1945, when the war was already lost. The technology that might have restored German submarine effectiveness arrived years too late, because American pragmatism had seized the critical window. The comparison between American and German military philosophy played out across every theatre. Germany produced 85 Tiger tanks that cost $250,000 each and required specialized maintenance. America produced 49,000 M4 Sherman tanks at $44,000 apiece that any mechanic could repair using spare parts from other Shermans. Germany built 1,500 Focke-Wulf 190 fighters annually using precision manufacturing. America built 16,000 P-47 Thunderbolts per year on assembly lines. Quality versus quantity stopped being a debate when quantity became overwhelming. The escort carriers epitomized this victory. They were unglamorous, slow, inadequately armoured, and built using shortcuts that violated traditional naval architecture. They were also exactly what the Atlantic campaign required: platforms that could put aircraft over submarines cheaply and quickly enough to matter. 50 escort carriers eventually served in the Atlantic and Pacific, sinking 69 submarines combined while protecting thousands of merchant vessels. Not a single one received the glory accorded to fleet carriers, but they won the war that mattered most.